Hello everyone, I hope you all are doing great. So today the topic that I've chosen is the magnetic field in terms of electricity. Now very first, if you're new to our channel, subscribe our channel. In addition, must go through the previous videos on magnet and magnetic field. So we all know that what is magnetic field? Magnetic field is the area around the magnet which particularly attracts things towards itself. The closer you are to the magnet, the more influence of the magnet the object will have. At very first, I have used the term electricity. What is electricity? Electricity is nothing but only the flow of electrons. You can refer it to the current as well, since this lecture would be specifically focusing on magnetic field. So it's not a worry thing that you're using current in terms to create magnetic field or either electricity. Just for now, will be looking into the flow of electrons. Now, what charge does electrons have? Electrons have negative charge, right? And how do we actually study the magnetic field in terms of flow of electrons? It's quite simple. What you need to do to understand this thing is to first take an wire. This wire is specifically conducting wire. What is a conducting wire? The wire which allows the current to pass through it is called conducting wire. Now you are actually letting the electrons to pass through this wire. Now these blue spots are electron passing by. Now whenever an electron pass by anything, they actually collides with the walls and then bounce back, collide with each other, creating a source of energy, creating a sort of energy within it that creates the magnetic field around itself. Magnetic field, which does not actually influence the electron, but it actually creates two things. One thing is that it starts attracting things. Second thing it do is to create the heat energy, which sometimes if you have just touched an wire in which it is functional, so it is usually hot. Why it is hot? Because electrons are colliding within that wire specifically, and they are continuously in collision form, creating the heat energy. So this is the reason why the wire is always heated. In addition, they are creating the magnetic field. If you have ever wondered that why our wires are actually covered with a thin layer of another coating, it's just to protect the inner copper wire. Usually in wires copper is used. Inner copper wire which is actually flowing up the electrons. That copper wire creates a sort of magnetic field. If you just pull down if you remove that coatings from the copper wire and then pass out anything, so that you can see the magnetic influence very clearly. In addition, here's how you can do the magnetic experiment. That this is a wire, and here's the passage of the electrons. Let me use red color for it so you will be able to see. Now electrons are passing by, and the thing that you are seeing here, this is the magnetic field. Okay, I hope that so far everything is clear to you. Now we do have a concept of the direction of the magnetic field. Just suppose for a while that we are given a condition that you have to find out the direction, how the magnetic field is working, from which to which side the North Pole and South Pole are performing its duty. So we do have a specific rule for it. Okay, let me just get up. Okay. Here you could see. that hand. This is called the curl hand rule. That's also in a curl hand rule. Also right hand rule. It's also termed as left hand rule. So far the curl hand rule is the appropriate name for it. Now very first, what do you do in this particular experiment? Let me bring that figure here near to this right hand rule. Sorry for this inconvenience. Okay, here our rule is. Here if you could see, we do have a wire. This is basically what? This is basically a conducting wire. And we all know that current always flows from the higher potential positive to lower potential. So here they have kept the higher potential downwards and lower potential upwards. So the direction of the current is upwards. In this situation, they have kept the higher potential upwards and this lower potential downwards. So the flow of the current is downwards. Now what this rule specifically states that first you need to keep your thumb in the direction of the current. Just suppose for a while here we do have the direction of the current upwards, so we'll keep our thumb upwards. Our hand is actually open, and here we'll keep our thumb downwards. Okay, now these two are the conditions. Now what we need to do, now we need to curl our hand, nothing but just curl our hand. Curl it, again curl it. Now in this situation, how our hand will be curled? In this direction, right? In this direction our hand will be curled. In this situation, in this direction our hand will be curled, right? So this is what the figure that we got here, curling of the hand, is the direction of the magnetic field. In this situation, the direction of the magnetic field is like this. Now if you can observe it, the direction of the magnetic field is now, we are known about that. Now one more concept here I really want to mention is that whenever you are talking about current moving upwards direction, so it is always anti-clockwise. And see, clockwise. If you're unknown about what is anti-clockwise, so just look into the watch or the clock hanging on your wall. Now how it moves, like 1, oh no, it's 12, sorry, 1, 2 and 3. In what direction does your needle move? It moves in this direction, right? So this is what? This is clockwise. And when an object is moving in this direction, just opposite how the needle of the clock move, it is called anti-clockwise. So the direction of the magnetic pole, whenever the charge is upwards, like our thumb is pointing the upward direction, it's always anti-clockwise, and whenever it's downwards, it's clockwise. I hope that all these statements, all these things that I've mentioned are digestible and you enjoyed the video. Thank you so much for watching our video. Stay tuned for future videos as well.